Greetings and salutations, all those nice things. Welcome to this lesson, 8.4, which has us looking at the reciprocal as a transformation. This is another one of our vertical transformations of the graph of f of x. And if we're looking at the graph of f of x and thinking of f of x as itself over 1, its reciprocal would have those two aspects of the fraction form change spots. So its reciprocal is 1 over f of x. Now again, as a vertical transformation, it's only going to affect y values. And we're going to take the y values on the original f of x and then take their reciprocals. Now, recalling definitions of reciprocals, we can note one way two values are reciprocals if their product is 1. It's a formal definition. In an informal definition, we're saying just take a fraction and flip it upside down. Take a quick second, fill in this table. Here's a whole bunch of values. What's the reciprocal of each one of those values? If you need to pause this video for like a whole minute, do so, but film in now. Oh, I don't know why I paused so long. Sorry if you were pausing the video for this. Too late. We're back. So the value is 4. Again, we can think of that as 4 over 1, in which case the reciprocal is 1 over 4. Same, we've got 2, which is 2 over 1. Its reciprocal is 1 over 2. The reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. And again, as you're writing all these down or have thought about them already, we're just recognizing if we multiply these two together, then we get 4 over 4, which is 1. Or if we multiply these two together, we get 2 over 2, which is 1. So reciprocals multiply to 1. Taking these two, multiplying them, we get positive 1. Reciprocal of 1/3 is 3. Reciprocal of negative 1/2 is negative 2. And reciprocal of 0. If we're thinking of that as like 0 over 1, its reciprocal is like 1 over 0. But division by 0, we know, is super undefined. Some keys in this, other than the fact that we're taking reciprocals of numbers, we're going to note reciprocal of 1 is itself. Reciprocal of negative 1 is itself, and reciprocal of 0 is undefined. We can also note that reciprocals might be higher or lower depending on what values we were working with. So reciprocal of 4 and reciprocal of 2, those are tiny values. Reciprocal of 1/3, though, that was a bigger value. And same, if we took the reciprocal of like 1/100th, that would be 100, becomes really massive. Or if we took the reciprocal of 10,000, 1 over 10,000, its reciprocal is 10,000. So as the OG number gets really close to 0, its reciprocal starts getting really, really huge. We can use that to graph a reciprocal. So we're given the function f of x equals half x minus 1. We can know that just y-intercept is negative 1. The rate of change, the slope is 1 over 2. So there's the equation of that line, but it is given to us. We don't have to find it. We are going to graph y equals 1 over f of x. So that is the reciprocal. We'll take all of our y values, take the reciprocal of them. Looking at this. Over here, there's a y value of 1. And the reciprocal of 1 is itself. Whoops. Over here, there's a y value of 2, and the reciprocal of 2 is 1/2. So approximately there. That seems like a good spot. Over here, we have a y value of 3. The reciprocal of 3 is 1/3, so kind of approximating again. It seems like a good spot. We also have this y value, which we can calculate as being 1/2. And the reciprocal of 1/2 is 2. Take a quick sec, fill in a few more points that you can find. Take reciprocals of y values, see what you get. Pause this video and then resume in like 2 minutes. Go. Alrighty, you paused, we're back. Let's find some more y values. Here we've got a y value of -1. Its reciprocal is -1. Y value of -2. Its reciprocal is -1/2. Here we've got a y value of 3. Its reciprocal is -1/3. And we've also got, let's go with this one. That has a y value of -1/2. Its reciprocal is -2. So we can try to connect the dotsies with this. Within each zone, the positive zone, the negative zone, we see kind of a trend forming, a curve that we could connect. So we could start connecting these for sure. I could do a better job with my sketchy lines. So playing connect the dots with the dots we have. We'll throw those in there. Now what happens to the rest? What we're not going to do is that. Those dots just don't connect to each other as a straight line segment all of a sudden. Trends that are established, they'd have to continue. So in that sense, where we've got this curve kind of going upward, it would want to kind of continue going upward. Where we've got this curve going downward, it would want to continue going downward. The reason why that happens is because as these y values get closer and closer to 0, their reciprocals start to really explode. Where we've established if there's like a point with a height of 1/10 in here somewhere, well, the reciprocal of 1/10 would be 10. That's already like off the graph somewhere. Oh my gosh. Nailed it. If we've got a point in here at the y value of like 1/1,000,000th, which is super, super close to 0, the reciprocal of 1/1,000,000th would be 1,000,000. It's huge. And so these values start exploding. This goes way, 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 way up, rocketing off way up into the sky. And it does that with this kind of force field barrier right when x is 2, because when x is 2, the y value is 0, and the reciprocal of 0 is undefined. We do have to draw this force field barrier in here to show that it does form a bit of a wall. And it forms that wall on both sides. So even here, with these values trending downward, we're taking the reciprocal of 1/10, or -1/10, which is -10, or the reciprocal of -100th, which is -100, or the reciprocal even closer in there somewhere, the reciprocal of -1/1,000,000, which is going to be -1,000,000. So those kind of explode in a negative direction rocketing towards negative infinity and encountering that force field barrier there. This isn't quite done yet. We've also got these ends to consider. What happens beyond those? And in one sense, we could say, well, there's arrows, so just put arrows. That does technically make sense. But what's really happening? On the right, we've got the reciprocal of 3, which is 1/3. At some point, we'd have the reciprocal of 4, which would be 1/4. At some point, we'd even have the reciprocal of 5, which would be 1/5. But this arrow is continually going upward. Sure, it's going rightward as well, but part of that, with its angle, it is going up. So at some point, it's going to hit a y value of 6, a y value of 7, a y value of 8, way over here somewhere. But it doesn't stop there. It's going to keep going upward. It'll hit a y value of 100. It will hit a y value of 1,000. And when the original function does that, the reciprocal will get the reciprocal of those y values. So this y value will keep trending in this way. It'll hit a y value of 1,000th. It'll hit a y value of 1,000,000th because the original y values hit those reciprocals. This is heading off to infinity. There's my infinity symbol. And as we head off to infinity, the reciprocal kind of moves towards 1 over infinity. If you have one cake and divide it among infinitely many people, everyone's pretty much getting 0. So this end of the curve is pretty much hitting 0. But because the numerator is 1, with that numerator of 1, the fraction itself never quite equals 1. Sure, everyone's getting crumbs, but it's more than nothing. So we put the arrow to say that trend continues. We try to get really close to this x-axis, and same on the other side. We can even continue this line a bit if we want, but it's going to try and get really close to 0. Never quite reaching 0 because technically 1 over something is not 0, but it's like 1 over 1,000,000. Like, you're getting 1,000,000th of a cake. That's not a lot of cake. It's basically no cake. Let's note some things. So one is that, reciprocals of 1 and -1, as we noted on the previous page, they are themselves. And graphically then, we had some intersection points where y was 1, where y was -1. We got the exact same point back. So with those points remaining unchanged upon transformation, we have these things called invariant points. And an invariant point is a point that, when transformed, remains unchanged. I'll just pause manually here for you to write that down, and then I'll keep speaking when I think it's been enough time. So again, an invariant point is a point that, when transformed, remains unchanged. It doesn't just mean, like for transformations in general, it doesn't just mean that the new graph intersects with the old graph. You're looking at a specific point and what happens in transformation to that specific point. Where does it go? And if it goes to exactly where it started from, then it is an invariant point. We can also note the force field barrier thing. This. That is called an asymptote. And an asymptote is kind of a force field barrier. At least the vertical ones are for sure force fields. We can't cross over a vertical asymptote. Very sad about those. That is caused because of that potential to divide by 0. Whenever we have a graph of f of x and we want to graph its reciprocal, I will immediately put in this force field barrier. I will put in this asymptote wherever the original function was 0. And I'll also immediately draw in my invariant points. This one is a vertical asymptote because it's going uppy-downy. There is also a horizontal asymptote for these. And there is one going right across this x-axis. And that one exists because the original function is trending off to some kind of infinity. So its reciprocal is then getting really close to 0. Again, because if we're talking about 1 over infinity, that's pretty much 0. But that's a trend as this function goes on in either direction. So those are things you're going to want to graph first. And then after you do that, then start playing connect the dots. Look at the general trends. Because those asymptotes are kind of guiding or tendency lines. The horizontal asymptotes will tell us what happens at the very extremes, way off on the right and way off on the left. And then the vertical ones, those are those force field barriers where we tried to divide by 0 and got denied. On the next page, we have a couple examples where we are just finding asymptotes and finding invariant points. These are state questions, so we don't need to show any work for them. But I'll take you through one. So stating the invariant points. Invariant points. That is wherever the original function had a y value of 1 or negative 1. And I see a couple of those. So there's the point -2, 1. So that will be an invariant point because the original y value is 1. And I also see the point 0, -1. Also invariant because its y value is -1. The reciprocals of 1 and -1 are themselves. For asymptotes, first of all, there's a spot where the original function value was 0. So for asymptotes, we can note there will be a vertical asymptote at this particular spot originating it, and it's going to make a vertical line go through right there. The equation of that vertical line, it's a line where x is the same the entire time. It's when x equals -1. For a horizontal asymptote, we're looking at the ends of the graph. Are either of them going off to some kind of infinity, whether that's positive or negative infinity? And since at least one of them is, we have one of those ends going up to positive infinity, or you can look at the right end and say it's going to negative infinity. We can note that there will be a horizontal asymptote. And that horizontal asymptote is going to be us flattening this out, saying eventually the reciprocals are pretty much 0. That asymptote is the x-axis. The equation of the x-axis, that's a horizontal line with a consistent y value. That y value is always 0. So again, summarizing, invariant points, that's where the original function had y values of 1 or -1. A vertical asymptote happens whenever y was 0. And then horizontal asymptote, we're saying if one of the ends heads off to either positive or negative infinity. So if we always go up or always down on the extreme, then we have a horizontal asymptote of the x-axis. Take a moment to pause this video and try the other two examples on the page. Give it about 5 minutes and then resume this video. Go! Okay, you're back. So I'm going to put in some sources. Invariant points. Pew, pew. One of those dots was smaller than the other. Nailed it. So I've got two invariant points. One is at the point 1, 1. One is at the point, I don't know, I can't count, 5, 1. As for asymptotes, there's a vertical asymptote. Oh, there's two of them actually. Boop, boop. So there's two spots where y is 0. So there's a vertical asymptote at x equals 2 and a vertical asymptote at x equals 4. Horizontal asymptote, at least one of the ends heads off to a kind of infinity. It does happen on both ends, so it's kind of superfluous to state such, but at least one of the ends does it. So there is a horizontal asymptote at y equals 0. Oop, didn't color code this. Pow, pow, and pow. Last one, invariant points. Whoops. That's wherever y was 1 or negative 1. And looking at this, I mean, there's no spots where y was 1. There's no spots where y was negative 1. There are no invariant points. So we switch to asymptotes. Vertical asymptote, wherever the original function was 0, so the original x-intercepts, but looking at that, I don't see any. So there must be no vertical asymptotes. Horizontal asymptote, at least one of these ends is heading off to a kind of infinity. It's a negative infinity, but it's still a type of infinity. So based on that, its reciprocal will try to hit 0. So we can get invariant points, we can get asymptotes. We'll plot those, and then again, just try to follow trends for the rest of it. So the next page has us actually graphing reciprocal functions. For each graph of y equals f of x, we're graphing y equals 1 over f of x. So that is the reciprocal. It doesn't say we have to state equations of asymptotes or anything, just graph the graph. So things I do right away. First of all, I take this x-intercept where y was 0, and I draw a vertical dotted line through it. Dotted to say it's not the actual graph of the function we want, it's just a guide for it. So there's that guide. Oops. Off. And similarly, because one of the ends was heading off to a kind of infinity, and same other end, I'm going to put that dotted line on the x-axis as well. Next thing, I check invariant points. There's a spot where y was 1. There was a spot where y was negative 1. So I'm going to fill those in. I've got dots. And then I need to form trends. Now, essentially, noting as y gets really huge, its reciprocal is going to get really tiny. So at the end, I'm trying to get really close to this x-axis. And I'm on the positive side of things, not on the negative side of things, because my original was positive. The reciprocal of a positive number is positive. Similarly, I know as I get close to this asymptote, I'm going to try and get really close to it, but at this top end, not at this bottom end, because I'm taking reciprocals of positive values, so my results are going to be positive. I can connect these pieces together, again using my sketchily lines. This might not be a 100% accurate graph. The points might not completely match up with where they're supposed to go, but the vibe of the graph is there, that I've got this vertical asymptote to trend towards. I've also got this horizontal asymptote I'm trying to meet, and this invariant point right there. So same for the rest of it. As we head to the left, we're going to try and get really close to that horizontal asymptote. As we get closer here, on the negative end, the reciprocal of those negative values will be negative, but getting close to 0 for the OG, the reciprocals are really trending towards some kind of infinity. And now I want to connect those three pieces, and I will do so with a gentle curve. And now that one is done. Done. I dare you to try the other one on this page. And of course, once you're done, you can work on some practice work. I'll have a couple things to say super quickly right after. But give it a try, give it a go, give it a spin, give it a shot, give it a whirl, give it a stab. Give it a wholehearted attempt. Pause this video for, let's say, 3 mins. And then resume. Do so now. Weckloam back. All right, it's me, Mr. What's-His-Face. He's going to plot some asymptotes. Do. And he's going to plot some invariant points. I don't know those exact coordinates, but I know y was 1 or -1 for all of those. Right side, I need to be negative this whole time. I need to stay in that box and trend towards this asymptote so I can fill that in. And again, staying in this box, I need to stay negative, but trend towards this asymptote. So I fill that in. I'll do the way left section next. Original was negative here, so I'm staying within this box, but trending towards those asymptotes. I could do that better. And finally, there's this middle chunk. Now, this whole thing was positive in there, so I need to stay within this box for whatever the reciprocal looks like. I do also need to get really close to this asymptote on the left and this asymptote on the right, so I can draw those components in there. then what happens in the middle? Well, I'm not going to just direct connect those. It should follow the same kind of curvature. When I do follow that curvature, I'm not going to like dip down beneath the x-axis, because that would be saying that the reciprocal of some positive value is some negative value. That doesn't make sense. So I must be dipping down a bit, but who knows what that amount is. I do, and you might as well. We're noting right at the peak, the vertex of this particular function, there's a y value that is, 3. That's the point, -2, +3. Its reciprocal is 1/3. So that is what we connect through. We reach that y value of 1/3, and then connect through to the other side. And then that one is done. Couple of quick notes to make. One is just in terms of drawing curves relative to asymptotes. What you definitely don't want to do is have the function curl away at some point. So right here, where we see the gap widening, we don't want that. And if we've got an asymptote, we should be clearly trending towards it and not kind of go towards and then change our minds. So don't curl away from the asymptote. That would be a communication error, which isn't the worst thing in the world, but still one you want to avoid. And same thing with these vertical asymptotes. So as this thing goes up, we don't want to have it go up and then curl away. And I'm kind of exaggerating what it looks like there, but I have often seen it where people draw this. And we can see there this curling away, that gap widening. So avoid that when you're drawing your asymptotes. Additionally, the most common issue with graphing these reciprocals is actually not graphing a reciprocal. Some people see this notation and they confuse it for that notation. These are both transformations we have now graphed in this unit. This is absolute value, has the absolute value bars. This we have to recognize as a reciprocal, taking f of x over 1 and flipping it over. That is taking a reciprocal. Don't get confused between these two. They are not same. So please be careful as you're doing that. When you're doing practice tests and practice quizzes, be aware of that difference. And that is about it. So again, work on some practice work, and I will see you in the future. The end.